So without further ado, let us move to our napakalupit na speaker, the almighty Gab. Gab
Oy, hindi
Benedicto.
malupit. Okay. Thank you for that introduction, JM. Can you guys hear me just fine?
Yes po.
Okay. I think we can proceed. Okay. Thanks for that introduction. So today, our topic is cloud, and cloud. So everything cloud. And just to set your expectations, we will be discussing the concept of cloud. So this has been around for how many years now? I think it's more than a decade already. So what we're gonna discuss here, and the target audience that this session is for, is those with zero to minimal knowledge in cloud. So this will give you an introduction what cloud is all about, why is it created, when was it created, and so on and so forth. So I will not be discussing some of the cloud tools, tool usage, but I will give a brief background and brief overview on how we use them. Okay. Um, okay, let's proceed. So here's our topic for today. So I'm gonna give you a quick introduction. What is cloud? So what do I need to know about cloud and cloud's XaaS? So we're gonna discuss that a bit in detail later. Cloud providers and some key takeaways. Okay. Okay. First of all, let's discuss some common terms that I'm not sure if you know or not or whatever. Yeah. Okay. Okay. When two computers communicate, what do you call this one? Okay, I think I pressed it too far. Sorry about that. Okay, when two computers or computing machines communicate, they communicate over the network, right?
Yes.
Okay, that's a quick example. How about if two or more computers are talking each other? What do you call it? What's the medium they want to communicate? Networkers? Other terms? What type of connection do we use? If we have more than two computer machines communicating with each other in a broader term. Guys, I'll be asking questions from time to time. I like to keep my sessions interactive as much as possible. So if you're going to have two or more computers connecting with each other, we call that connection internet. Okay. From the word itself, I think there's a big difference between internet and an intranet. So I'm going to discuss that also as well. Um, so when you have everything, when you add mobile into the mix, what do you call it? Chess LG server. I think this is from earlier. How about this one? When you have competing machines and mobile applications communicating with each other, what do we usually call this? Anyone? Any guesses? Any guess? Okay. So when we have this, it's now called, I think, mobile internet. It's a more generic term, but now we have mobile into the mix. That's why we have this mobile internet. That's how we call it. Okay, next. How about if you add people in the mix? What is the common term? Any guesses? Any guesses? Come on, guys.
Any question, Gab? Sorry.
The question is, when you have computing machines, mobile internet, and you add people in the mix. What do you call this type of communication? Intranet. Close. We're gonna discuss this later, Nigel. But somehow close. We add people in. Yes. So the PC mobile plus people is actually sometimes called the social network when you add the PC, mobile, and people into the mix. So actually, there's a broader term. We have this people in the mix now. So it's not just the machines talking. So it's more on a social network. So that's PC plus mobile plus people. How about if you add everything in the mix? I think this is the last question that I have for this slide. Thank you, Lian, for that answer. How about this last one? Cloud computing. Close? Yeah. But I think cloud computing is very diverse. This session is actually part of a series of skill brewing sessions. So we have cloud computing, we have edge computing, and we have fog computing. So right now we're discussing cloud. If you're interested with other two, edge and fog, just register. I'm gonna have it scheduled sometime soon. So when you have this, like June said, actually this is Internet of Things. When you put internet, when you connect your things, your house, your car, your train, your building, everything, you will call that Internet of Things, or in short, IoT. Okay, so these are just some of the terms that I will be using throughout the slides. So please get yourselves familiarized with it. Okay, finally, so what is cloud then? Cloud, as we mentioned, have three fundamental concepts. So when we say cloud, please imagine these three fundamental concepts. Okay. First, when you say cloud, these are your services served as utilities. Okay. Please take note of the word as utilities. So if you have a computing hardware, you have a storage, you have software, and if it's served to you as a utility, something that you use, diba? From the word itself, from the root word of utilities, utility. If you use it, this kind of service, like a computing service, that's a concept of cloud. Okay? Later on, i-discuss natin yan. We're gonna deep dive onto this information. Right? So if a service is served as a utility, you can use it. Example, your laptop have their own memory, right? But you can extend that memory somewhere in the internet. So that storage service is served as a utility. So that's actually a cloud service. Right? That's the best example I can give right now. Okay? The next concept of a cloud, if you have computing resources that is currently being shared. Okay? So when I say computing resources, these are your machines that does your computing for you. That's the root word of the word computer, to compute. So if you have a computer, a machine that computes anything for you, and it's currently being shared, which in the cloud we call it virtualization. That's one of the concepts of cloud. Okay, so we have services as utilities, shared computing resources, or what we call virtualization. That's the second concept of cloud. Third and final, if these services are served via network. Okay, so it can be served over the internet, as I mentioned in the previous slides. Okay, quick question. I think it was mentioned na here in the chat box. What is the big difference, or what is the difference between internet and intranet? A little history lesson or English lesson for you guys. Internet versus intranet. June, within versus outside. Okay, thank you. So when you say internet, from the prefix itself, yes, intranet, Gian said intranet local, internet is equal to online. Yes, thanks for that. Private and public from Monty. Okay. So just to, if you encounter words in IT, sometimes kasi these IT people, they use their heads to name things. So kinda it makes sense. So internet, from the prefix itself, inter, okay? Inter, in the English vocabulary, it means between, okay? So internet basically means between networks, okay? So that's internet. And the World Wide Web is the network where the internet lives, okay? So your machine and my machine communicate, and other data centers can communicate through the World Wide Web, through the internet, okay? That's internet, between networks. So that's the root word of that. Intranet, on the other hand, from the prefix intra, which means within, you're communicating within the network. So as mentioned by June, it's within the network. By Gian, it's local. Intranet is local to your network. And Monty said it's private to your network. So if you have organization, you have a business, if you want to set up an internet, meaning your machines can only communicate between that network, you call that intranet. Okay, so that's slight English lesson for you guys. Intra versus inter. So yun lang yung root word done. That's it. Okay. So the concept of cloud is something like this. So if we have derp, and let's name this derp Jambay. So if we have Jambay who have a laptop, so in this laptop, he's gonna install an application. So from the first part, okay, we have Jambay who have his own computing machine. Let's say it's like a laptop. So he's gonna install some applications. He's gonna install some database. He's gonna install some hard drives. So this is his computing machine, right? And currently, it's currently limited to this application, so this database, to this hard drive. So if another person, DJ, we call this another person DJ, he also have his own laptop. So he's gonna install his own application, his own database, his own hardware. So this is the typical setup, okay? It's a typical setup of a computing resource. So this application installed in there, using this database, using this hard drive, okay? So something like that. But in cloud, if we have multiple users, if someone wants to use this, he's gonna use the resources from this laptop, from this hard drive, from this application. But in cloud, when you have multiple users, again, the concept of cloud, all of this are being shared virtually. Okay? As we go back here on the last slide, we're gonna serve it as a utility. It's gonna be shared computing resource, and it's gonna be via network. So all of this will be converted to this. You have one big application that's being deployed somewhere on the cloud. You have a database somewhere on the cloud. You have the one hardware somewhere in the cloud. Okay? So this is, I think, the visual difference of having the bare metal, or what we call the old school type of computing resource deployment, versus what we have in the cloud. Okay? That's a quick visualization. Any questions about this slide? None? Guys, if you have any questions, just cue me in. I'm reading the chat box naman from time to time. Okay. So here's another visualization. Visualization again on how it looks like in the World Wide Web. So here's your computer talking to private servers who we think have their own intranet, their own networks, right? And it's what do you call this one? I think everyone knows this. What do you call this one? Yes, that's the firewall. So usually, these intranets within the organization, if you want something to be protected, you want a firewall to be installed. So not physically, but virtually. Yeah. So we can say that this illustration above has their own intranet. And this is actually a data center, so just a computing resource, nothing else. Protected by a firewall. They are connected through the World Wide Web, and this is your internet. Since, as we mentioned, internet is a communication between two networks. Okay, between networks, not just two. So here's your laptop. So you connect. So if you have an application and it's served over the internet, let's say www.illustrados.co, it's gonna connect to the World Wide Web via the internet. It's gonna find where Illustrados.co is installed. Okay, it was found here. So it's gonna return the website here and so on. So just a pretty visualization on how it's going on. So basically, when you do that, you actually virtualize the installation of your website because Illustrados.co is not actually installed on your machine. It's actually installed somewhere else, somewhere in the cloud. Remember the concept of cloud. It's services over the network. It's a shared environment. So in these data centers, in these computing powers, there may be other applications that's installed. And this is what we call the cloud providers. So I'm going to discuss that as well later. Okay, so just a quick question. Why do we need to do this? Can you guys give me, I think, on top of your head, why do we need to do this? This one. Why do we need to do this instead of this? Right now, even if you don't know what cloud is all about, can you guys give me, why do you think people are moving or companies are moving from this setup to this setup? To save money? Yes, Queen. Thank you. From Cavite. It's easier to maintain. Yes, thank you. We're gonna explain later why it's easier to maintain. Can be accessed anytime. Yes. Easier to move with. Yes. Protect data technically. Yes, you can protect your data within local hardware, but we're gonna explain later why it's have a better protection when you deploy it in the cloud. Okay. Thanks, Gian. How about the others? Why do you think we need to move our services, or what's the need? What's the advantages you can think of? Why we need to move away from locally sourced computing machines to cloud hosted one? Efficiency, yes, Lian, that's correct. Safety and accessible to everyone, okay? Yeah, I think everyone have an idea, no? The advantages of cloud. Anyone else? Thanks, John. Okay. First off, oops, sorry. Cloud computing resources can actually do dynamic scaling. Can anyone tell me what is the difference between a vertical scaling versus horizontal scaling? Come on, guys. Anyone knows the difference between vertical scaling versus horizontal scaling? Anyone? Okay. Chess said large volume of data versus diverse. Monty said additional hardware versus additional servers. Power versus resources. Okay. Yes, thank you for that, John, Chess, and Monty. So, in vertical scaling, if we're gonna go back to the diagram before, okay, this one. Let's say this is a computing machine of someone from a big university. And this is the hardware, or let's say this is just a single data center, a bare metal server from the university itself. Okay? Let's put a bare metal server here. Let's just imagine there's one. In that bare metal server, the applications installed, the registration portal, the attendance portal, the teachers portal, the attendance portal, wherever. So you have your database, you have your hard drives. Okay? So just imagine this one. The school has this. What do you think will happen if the following year the students number doubled? What do they need to do? What does the school needs to do? Increase storage. Yes, so you're gonna increase everything, right? So you're gonna increase your computing power, you're gonna increase your storage, you're gonna increase everything. So let's just say hypothetically, your memory can serve 1 million students with 100,000 concurrent users and 10,000 concurrent applications. So that's your current capacity. If you double it, you're gonna buy another set of memory. You're gonna buy another set of NAS storage and so on. Okay, so that's vertical scaling. You're actually upgrading your computing resource. So from this small, you're actually scaling upwards. In a personal sense, if you're gonna scale your laptop, you're gonna increase your RAM, you're gonna increase your hard disk, and you're gonna increase everything. So that's vertical scaling. However, what happens on the following year? So let's just say you upgrade. The following year, the students have been pushed down until the 500,000 mark. What do you think will happen to the resources? Diba? You already purchased it, but your system can now handle up to 2 million students because we upgraded it, right? We doubled it. Your database can handle 200,000 concurrent users, and now your computing resource can actually handle 200,000 applications because you already doubled it. But now on the second year, it's now half. But you already purchased it, right? So that's one of the disadvantages because you already purchased it. It's now in your hands to maintain, and it's consuming electricity because now it's more powerful. It's consuming more power. However, when we say horizontal scaling, okay, so instead of doing that, instead of upgrading the existing resources that you have, you will actually add the same amount of resource. You will scale horizontally. Okay, and there's so many advantages to that. So instead of increasing the performance, you're gonna have a whole set of these, a whole copy, another database, and another NAS storage. Okay, so that's the difference. Increasing vertically, upgrading your current computing resource, or you're gonna scale horizontally. You're gonna have the same database. Let's say the power is 1 million. Yeah, I said 1 million users. You're gonna have two database, okay, that can handle 1 million each. So you're not gonna have one database that can handle 2 million users. Okay, that's the big difference. So I'm gonna discuss later why is it an advantage. Okay. Next, so cloud computing is actually cheaper. Because as I mentioned in the example before, you're gonna pay on what you use. So if you're gonna have to buy everything yourself this year, and the next year you are only using half that resources, you already spent that much. But if you're using cloud, you're only gonna pay what you use. Okay, so if you're using 1 million transactions this year, next year you're using 500,000, so you're just gonna pay for that. So it's the payment also scales on how you use it. This is the current competition right now. Almost all cloud providers do this. I I haven't seen any cloud providers that doesn't have this business model. You only pay what you use. And it's so cheap. Like you're gonna pay $0.0004 per hour, something like that. Okay? And next. So reliability. So that one of the advantages of having cloud service is actually it's more reliable. So why do you think so? Why do you guys think that having your applications in the cloud is more reliable? Remember, we have scaled. Yes. Why do you think? Yeah. Thanks, Gian. Why do you think it's up always 100% of the time? Yes, it has better security options. The power is handling the maintenance. The provider is providing the maintenance rather. Okay, actually, it's a combination of these answers. So if you have outsourced your computing hardware or computing resources to the cloud, it's powered by data centers and never goes down. Yes, because these these companies, these cloud providers have an SLA. Okay, if you have heard of the term, you can research this right now. 6 nines, 7 nines. That's actually an SLA, a service level agreement that you will have your cloud providers. They're gonna promise this that when you have your applications deployed to our cloud service, we're gonna give you 5 nines SLA. So research nyo lang yan kung ano ibig sabihin yan. So basically, it's just a number. 5 nines, 6 nines, 7 nines, something like that. So if you have outsourced it, the cloud provider itself maintains these services. You don't have to worry na your application will go down. Your data center will go down because it's the cloud provider's job to make it up 24/7. And there will be a breach of SLA if they don't hold to their promise. Now, 5 9 availability. Can someone compute? I think 6 nines availability is actually, they will say that your application will only be down like 30 minutes a year. Something like that. Don't quote me on that. Quote me on that, okay? Just research it later. So having your applications deployed to the cloud is more reliable because they have this in their SLA. Okay? And then, remember, we already scale dynamically. So cloud is using a horizontal scaling type model. So if one database can handle 1 million concurrent users and the other database can handle 1 million concurrent users, when that database goes down, it can dynamically scale anytime. This is the current setup right now. I know it sounds kind of magic, but it's currently happening. Okay? It will create another server instance for you in the cloud, and it's gonna install another database for you while they are troubleshooting why this instance went down. So that's their job. It's not your job anymore. And for those who are DevOps engineer, actually it's your job to do that. So in a more advanced cloud topic, I'm gonna discuss this and how we do it. So I've done that several times now. Back when I was working with doing this for AT&T and Sprint. So that's with Accenture and IBM. So we make sure that all our database are available 24/7, and we have put enough precautions to let this happen. And I think just to add, I can remember and how often do we have to do this. During the testing phase, if you want to test one feature, we have this automation that we will install just one click of a button, okay? We're gonna spawn off a new server. We're gonna install the application that we just built. We're gonna install a new browser. This is just one click of a button, and we're gonna run the test. And then after all the tests has passed, we're gonna destroy that server in just a span of 30 minutes. So that's how we manage the computing resources in just one click of a button. And that's actually okay. Many companies are doing it. They're gonna create a virtual server anytime and destroy it 30 minutes after just to test something. Most containers do that. Okay, high availability. So your applications are now even more available to the world since cloud providers are already connected to the internet, it just means if you need to access your application, you just need to be connected to the internet. Okay? So internet connection is enough. That's it. So with this, I think it's tied that if you have your application's high availability, it's actually more flexible now. You can access your data in so many ways, not just the internet. You can actually access it in any ways, like you can create your own APIs, you can create your own dashboards, and so on and so forth. And that's it. Okay, number 6. Okay, we're gonna. I think we're been hearing this a lot. Why do you think it's more safe or more secured to have your applications hosted in the cloud instead of having your own data center, your own bare metal servers in your organization? Why do you think so? Come on, guys, type it in. Um, Anything? Anyone? I cannot see anyone else. Encryption, yes. But Chess, we can actually do the same encryption in our local bare metal servers. So, given the analogy earlier, if you have a school or organization and you have your own data centers, I can actually if I was assigned to that to maintain that data server, I can provide the encryption. What do you think it's more secured? It's actually tied to how a cloud is modeled. Anyone? Okay, so since applications are deployed in a cloud, VPN. Yes, you can actually create a local VPN in your local bare metal servers in your local data center. Okay, so let's compare. Let's use the analogy earlier. If you have your own local data center and your own bare metal server, you're gonna hire an IT team to maintain that data center, right? You're gonna hire a security team to make it secured, and that's not cheap. Okay, that's not cheap to hire your own IT team. You're gonna pay for that monthly, and that IT team, you need to train them monthly on what's the latest, and you should have them check every day or regularly that the server needs to be patched, needs to be upgraded, needs to be monitored, and so on and so forth. So that's the local IT team. In comparison, if you have your applications deployed in the cloud, rest assured that these cloud providers already have the latest. They have the best of the best cloud engineers working 24/7 to make sure that your applications are secured in the cloud. Or rather, I say secured in their data center. It's actually their job. It's actually included in the clause that your applications cannot be hacked when it's deployed on our cloud instance. So if you're gonna pay for the hour, cheapest by the hour, $0.0004 per hour, it's already bundled. It's always up. You don't need to hire an IT team. It's already secured because these cloud providers have the best of the best engineers. They do that every day. In comparison, if you're gonna build your own IT team, you're gonna need to train them every day. You're gonna need to have them updated regularly. It's not cheap. Okay, that's why it's more secured in the cloud. Amazon, Google Cloud, Azure, DigitalOcean, all of them already have their own security team of engineers taking everything for you. You don't have to pay for a separate IT team. Okay? I hope that's clear. Let me know lang hindi. So, efficiency. So as mentioned, what they are doing right now is that they're buying this computing resources in bulk. Let's say just one data center can serve 1,000 applications at the same time. So in comparison, let's just imagine if 100 businesses will buy that kind of resource in computing power, right? You will have 100 data centers and it's not being maximized. Sayang lang yung computing power na binili nila. It's not being maximized at all. However, if you have someone from a cloud provider that lets you, you just pay for what you're gonna use, they can maximize each data center. They can maximize the computing resources allocated per data center. Okay, for this time of the year, this data center will hold 1,000 applications. So what if one application stopped using your cloud provider? They're just gonna replace it with another application. So every data center is maximized. Okay? Compared if you're gonna host it locally, if your data center have a 1 million computing power, just hypothetical, and your users went down, you're still using that same power, same electricity, same power, and you already paid for it. So it's not that efficient. Okay? So in cloud, your power and what you use is actually dynamic. You only pay for what you need or what you use, sorry, rather. Okay? Any questions on the 7 advantages of cloud? That's too much information to take in, but let me know if that's not clear. Okay? That's why cloud is really on demand right now. Everyone is moving into the cloud. No organizations or no companies wants to maintain their own data centers. Some they say it's very it's for security or something like that. No, there are lots of companies already in the cloud, and it's more secured than you can ever think. It can be set up in many different ways. There's so many ways to skin this cat, and I can think of right now 5. I have done 5 security features so that no one can access our um, resources in the cloud. So I think that's already 5. I did that 5 architecture wise. Okay, cloud and XaaS. So when you hear the term SaaS, what is the first thing that will come to your mind? SaaS. It's a very common term. Even though you're not in IT, you should know this. What is SaaS? Anyone? SaaS, software as a service. Yes, Mon. What's the first thing that will came to your mind? What the hell? What's the first thing that comes to your mind? SaaS. Okay, nothing. Okay, so SaaS basically it's like your softwares. Instead, you have this installer, diba? That's how software is distributed before. You have your own installer for a software. You install it on a particular machine, and only you can use it. Okay. However, as we mentioned, one of the concepts of cloud is the service as utilities, right? So we have these softwares installed somewhere, and then you can access it via network. One sample of that is internet, right? You can actually have an application installed locally and access via the intranet. That's also cloud service, since you have not installed it locally to your machine. Okay, so mostly software as a service have this server, storage, OS, or package softwares. It's targeted for end users. So on top of your head, what do you think is the most common, or can you just give me an example of a SaaS? SaaS. Office 360. Yes. So before, you can only use Microsoft Office offline, like locally, right? Now you can actually access your Microsoft tools online. Another one, CRM. There are CRM locally, and there are also CRM deployed in the cloud, which everyone can access anytime, internet or internet-wise. G Suite, okay, that's a good example, Patricia. So before, I'm not sure if I can, hindi ko to naabutan na, hula ko lang to. Just a guess, before you can have an email, like a company, you need to buy your own server, install an SMTP, install a network, install everything, bash, and then actually install the mailing service. Then eventually, the system admin can finally add accounts to that mailing to that SMTP server. And then finally, your company can have an email. Diba? You can use gab@illustrados.co. But now, how easy it is to create an email. You just need a telephone number, and Google will provide you an email account for free. Did you install the Google Mail? No, because Google Mail is a SaaS. It's a mail software as a service. Did you install? Did you install anything for Gmail? No. Does your mail took up storage in your local laptop? No, because everything is in the cloud. Google is providing it free. Okay, I think it's 15 gig. Okay, next, pass. What do you mean by pass? Pass. Platform as a service. So platform as a service, so you have, so instead of the software itself being deployed in the cloud, you can actually use a whole platform. You can actually rent, what you can say, or pay for a server, pay for storage, or pay for the network itself. So this time, you don't need to hire Cisco certified IT professionals. You can actually pay and have someone install it for you, like a cloud engineer, or you can have everything rented on the cloud. Okay, so this is targeted more on software developers. So we're gonna give examples later. Okay, finally we have IaaS. What do you mean by IaaS? So if software, we're paying for server, storage, always and package software. Platform, we're paying for the service, storage, and the network itself. What do you mean by IaaS? Infrastructure. Okay, so we're actually renting the whole infrastructure itself. So it's still the server storage network, but more on a deep level. So you're actually paying for the whole server, nothing installed. Okay, so if you want, you have root access to everything. You're actually buying a space in the cloud. So ito na yung pinaka bare minimum. I mean, the deepest level that you can get. You will actually pay for a cloud server. And when it arrives to you, it's just blank. Okay, so you're gonna install your own network, you're gonna install everything in your own database, so on and so forth. So these are geared towards infrastructure architects. Okay. Okay, I think I got 3 more slides left. So for SaaS, as I mentioned before, and Patricia then, sabi niya, also everything on the Google Suite, all of this, actually software as a service to. Kasi you don't need to install additional network drives for you to have more storage, right? You just go to your Google Drive link and you can put anything in there as long as you pay for it. It's very cheap. This is example as well of software as services, Keep, Sheets. The equivalent of this one from Microsoft is actually the Microsoft 360. You have your own chat software. Diba? You can use chat.google.com without installing anything. This is, I'm not sure what this is one, but this is Blogger. Hindi ko siya nabutan. Classroom, and so on. So those are your typical examples of SaaS. For PaaS, so I think it's obvious. I'm a fan of Google. If you're gonna rent or have your computing resources platform as a service in the cloud, you're gonna have to look at Google App Engine. So you will have your own app engine deployed for you, and you can actually install your software there. If you have a this is perfect for those who have their own custom software applications. Okay. Um, so if you have a software, you need a platform to deploy it. Use Google App Engine. It's so good. It's so cheap, and you have so many services to choose from. Baka naman Google. Okay, so lastly, IaaS. So if you want just the computing hardware, computing resources um, deployed, or if you want to use that infrastructure, go to Google Cloud Platform. So you will have your GCP. So hindi ko kabisado to mga to, but I think this is Kibana, this is Lags. Okay. Hindi ko kabisado yung mga icons na yan, but the Google Cloud Platform is your go-to if you want an infrastructure as a service. Okay. Moving on. So last slide is we have the top cloud providers. So if you want to know more about them, so I think right now, surprisingly, Amazon's revenue over the years actually is not coming from Amazon store. Most of its revenue is actually coming from AWS. So it's they are a cloud company first before they are a retailing giant, like we all know. Next is Microsoft Azure, Google Cloud. So I mostly use this all the time. Alibaba Cloud, I haven't used this. Salesforce used it somehow. DigitalOcean, yes, they call their applications droplets. Dropbox, haven't used. IBM, haven't used it as well, even though I'm from IBM before. Ayan, bonus, last slide. Has anyone heard of the term Cloud Kitchen? Cloud Kitchen. Actually, it has the same concept. Same concept as cloud. Anyone? So just like, I think those who attended my Agile session yesterday, as I said, diba, Agile is being used in companies, not just in software development, but actually in all industries. And then Agile can also be used for planning in life. In here, the cloud concept is not actually limited to computing resources. The cloud concept is also applied to real life scenarios. So one example for that one is the cloud kitchen. So the concept is the same. Instead of one community, actually this is happening right now. If you have 10, let's say fast food, 10 different fast food around your neighborhood, that means they will have to buy 10 different grillers, 10 different, salamander ovens, 10 different everything, 10 different everything. Yes, Gian, thank you. That's correct. And as you can see, paano na lang, what if one restaurant doesn't have enough customers per day? So, sayang lang yung resources niya, sayang lang yung gas, sayang rent fee for the place. You cannot maximize the resources because if you have 10 different businesses serving the same kind of food, the customers will also be distributed. Cloud kitchen is gaining popularity is that there's this one big kitchen that you can rent and then you can just utilize what you need. Okay? So it's just like 10 different kitchens in just one big 10 different restaurants in just one kitchen. So if you're gonna use this, you're gonna use that, you're gonna only pay for that one. All those 10 restaurants are actually sharing for the rent, sharing for the grillers because not all the time they're using it, diba? So everyone is sharing with everyone. So that's a concept of cloud kitchen. If you want to research this, you can actually um, dark kitchens. So it's actually a trend right now. Sometimes they don't have a physical store. Sometimes they have. It's only for delivery because inside the kitchen there are 10 different restaurants. Okay, Uber for X. So the concept of Uber when it was invented, it's actually so many different concepts that came after Uber. So Uber for X is actually the middleman for something. So Uber doesn't own any cars, but it actually connects um, people who wants to ride for those who wants to offer a ride, and so on and so forth. So it's like X as a service, as I mentioned earlier. So Airbnb is hotel as a service, something like that, no? So what else? Delivery as well. Delivery is already a service, so something like that. So there's so many applications right now with the Uber for X or XaaS model. And okay, I've that's my last slide, and I hope you guys learned something today. And there's so many terminologies I discussed, so many new words, and I hope you can actually join us on our next session. We're going to discuss cloud computing 101. So that's a slightly advanced session than this. We're going to do um, actual computing in cloud. So we're going to have something deployed. We're going to create templates, blueprints, and then we're going to see how it goes and how it's being deployed and managed in the cloud.